Hi you guys, today I'm going to be addressing the precise definition of limits. This was a school project, calculus project for us, and we got to choose any topic we wanted, so I chose the precise definition of limits. I hope this helps anyone who's having difficulties. I chose an example straight out of the books, that way if anybody was having trouble with that example, they could refer back to it. It's on page 107. So the precise definition of limits will often be given to you in terms of delta and epsilon. Most of the problems are just determining if delta is given, you'll be asked to determine the value of epsilon, and if epsilon is given, you'll be asked to determine the value of delta. And also I want to apologize for how this video is going to go because my camera is being dumb and it won't change sides, so I'm just going to have to hold the paper up. So sorry about that. So this is the first graph, if you can see this. So the function given was if the absolute value of f of x minus 5 is less than epsilon whenever 0 is less than the absolute value of x minus 3, which is less than delta. So with this graph, you'll take f of x minus 5 and locate that as epsilon. So on this graph, 5 is right here, and going along here, you'll see that it is in line with 3. So epsilon, they gave you a value of 1. Since they gave you a value of 1, that means you have budging room of being allowed to go up 1 and go down 1 on the epsilon, for epsilon. So that means that you'll be able to look at the value of x when epsilon is 4 and when epsilon is 6. So if you go along the axis when epsilon is equal to 6, you'll see the delta is equal to 5. And when you go along the axis when epsilon is 4, you'll see that that's equal to 1. So you plug in those two values. So when you plug in the value to 0 is less than the absolute value of x minus 3, which is less than delta, you'll find that when you plug in the two values of x, which are 5 and 1, 5 minus 3 is 2, and the absolute value of 2 is just 2. So when epsilon is equal to 1, then delta is equal to 2. And since you had two values for epsilon, you'll also do the same thing when you get a value of 1. So 1 minus 3, right here, 1 minus 3 is negative 2. The absolute value of negative 2 is 2. So epsilon in both cases are equal to 2. I'm sorry, delta in both cases are equal to 2, or any smaller positive value. So another example is if epsilon is given an equal to 0.5 or 1/2, if you follow along this graph, you'll see that when epsilon, you're given a budging room of 0.5, you can go up 0.5 from the value of 5, given that the absolute value of f of x minus 5. So that will equal 5.5 and 4.5. So any y values from in between those. So when you have a value of 5.5 and you go along that axis, delta will be equal to 4. And when you have 4.5, delta will be equal to 2. So you have your values, your two values of 4 and 2. So 4 minus 3, plugging that back into the equation for the same function, 4 minus 3 is 1, and the absolute value of 1 is 1. And 2 minus 3 is negative 1, and the absolute value of negative 1 is 1. Well, I hope this helped you guys. I'm sorry if I was complicated, but I hope I did well. Thank you.